All right. Two things are going to happen today. The first thing is I'm going to go over the answers from yesterday's math work. So I want you to make sure that you're checking your answers. So get your notebook and do that. The second thing that you're going to need is a piece of blank paper. If you have a piece of like printer paper that's blank, use that. If you don't, go ahead and rip a page out from the back of your notebook and use a piece of binder paper. What we're going to do is we're going to make this tiny little like open booklet thing that I'm going to show you, and then we're going to glue it into our notebook. I don't know if we did it before. I don't think so. So again, you'll need a piece of paper that we'll glue or tape into your notebook, and then you need to check your answers from yesterday. Okay, so let's go ahead and check our answers from yesterday. Page 225, 1 through 5 only. The sum of 4 and p is 4 plus p. The difference between 8 less than q. Remember, 8 less than means that q comes first. Q minus 8. This is your key word here. Less than means the q has to come first. Number 3, the product of 3 and r is 3r. Remember, we don't use a multiplication sign. We put them next to each other. The quotient of s and 5. Okay, and remember I showed you yesterday in our notes that s over 5 is how you will see it. So get used to writing it s over 5. Number 5 had a couple different answers, and I know probably the last one might have been the hardest, so let's go ahead and look at that. Cheryl is now X years old. Okay. How old is Cheryl's father? If he is 24 years older than Cheryl, he is X plus 24. X plus 24. This one, you could also write 24 plus X and it would be correct. But get used to seeing the X first. The variable usually goes first. B, Cheryl's brother is 2 years younger than Cheryl, so it is X minus 2 years old. And I added these years old in there because we're talking about years. C, her sister's age, she's twice the age of Cheryl, so 2x. And then D was a little bit tricky, and there's two possible ways that you can do it. You can write her cousin is 1/3 of Cheryl's age, 1/3 times x, but 1/3 times x is the same as saying x over 3. These are both correct ways. Because here we're assuming the 1 goes with the x, so it's like 1x divided by 3. Reciprocal here comes into place for those of you who know that word, reciprocal. All right, so give yourself a score out of 8. 1, 2, 3, 4, 5, 6, 7, 8. And remember, if you did not get them all correct, that's okay. This is brand new. All right, once you have that, we're going to go back to our notes section, and you're going to take that piece of paper that I asked you to get. All right, and today we're going to talk about properties. And I'm writing the title properties, but I'm going to set my notebook aside for now because I'm going to write on the piece of paper that I had you get out. So I'm just going to write properties. I'm going to either glue stick or tape that paper back in here when we're done. So I'm just going to put it to the side for now. Okay, this is might be a little bit hard to see because my paper is white and my table is white. So we'll do the best we can. All right, the first thing I'm going to do is I'm going to fold my paper in half, hamburger style. Okay, so here's what your paper normally looks like. If it's a piece of binder paper, your holes are on this side. 1, 2, 3. I just fold it in half, hamburger style, not lengthwise. Okay. Now what I'm going to do is I'm going to take that fold and I'm going to fold this top part down to touch the middle fold that I just made. And then I'm going to do the same thing with this bottom part. I'm going to fold it up back to that middle line that I just made. So my paper looks like this. It opens like this. And then I'm going to take it, fold it in half, or fold it the way it is, and fold it in half. So this will go up. So my paper should look like it has 4 little windows and then this back. So what I'm going to do is now I'm going to take this part right here that I folded, and you can either cut it with scissors or you can rip it if you rip very carefully. So that I have little flappy windows that open. And I'm going to do it to the next side. If you're not a good ripper, then I would suggest you get some scissors. Okay, and that's it. Okay, I want it to be like this. And you open a window here, you open a window here, a window here, and a window here. And this is, we're gonna write on everything. Okay, properties are something that you have been talking about, I know, since probably 2nd or 3rd grade. So some of these will be new, some of them will not. So I'm going to start, here is my little booklet, and I'm going to start in the upper left corner, and I'm going to zoom in so you can see what I'm writing in that upper left corner. And on this will be the cover, I'm going to write commutative property. And commutative property is a word, and when you think of commutative property, I want you to think of the word commute. And commute is something that we all used to do before shelter in place. And if you've heard the word commute before, it means when you travel from one place to the other. So for example, my commute from my house every day used to be from San Jose to Zanker, and from Zanker back to San Jose. That's how I would drive, and I would take the same roads. When you leave your house in the morning, you would go from your house to Zanker and then Zenker back to home, most likely. That's your commute, okay? And that's your key. I'm going to draw a little car. Don't laugh. Make your cars look better than mine. I'm going to draw a little car commuting on the road. Wow, that was bad. This was my car from last time. Much better. All right. Commutative property. Think commute from one way to the other. And the reason why I have you think that way is that now I'm going to give you a definition of what it means. And we're opening that little one, and that's where we're going to write it. Okay? Addition and multiplication of numbers can occur in any order. And I bet once I show you my example, you'll know what I'm talking about. 2 plus 4 is the same as 4 plus 2. So when I think about it, I think about San Jose to Zenker is the same as Zenker to San Jose. It's the same way. I take the same route. It means the same thing. It doesn't change the value. It doesn't change at all. Let me give you another example with more than one number. 6 plus 9 plus 7 is the same as 7 plus 9 plus 6. All the same digits, just the way that I add them doesn't change the value. 3 times 8 is the same as 8 times 3. 2 times 3 times 4 is the same as 4 times 2 times 3. You can put them in any order and the value you get will be the same. 2 times 3 is 6. 6 times 4 is 24. 4 times 2 is 8. 8 times 3 is 24. You get the same answer. So back and forth. Here, I'll put a little house here. That looks nothing like where I live, but that's okay. It's a house. That's commutative property. All right, now I'm going to go over to the right hand on the top, and I'm going to write associative property. And I want you to think of the word associates. And some of you might know the word associates. Associates are people you know. They are, sometimes you'll say, oh, I associate with those people. So Zenker teachers are teachers that I associate with. Okay, that we're a group of people that know each other. Okay, so your key word here is group. And I'm going to write some little people here. My little stick figures. This guy will wear a top hat. Okay, they're in a group. I'm going to say groups. And the group part is really important. And you need to know the group part because I'm going to show you why it makes it different from commutative property. All right, so now I'm going to open this. Addition and multiplication grouping of numbers can be different. So let me show you what that means. And when we talk about groups of numbers in algebra, in expressions, in equations, we use parentheses. That's how we know there's a group of numbers. You have seen it in PEMDAS. So 4 plus 3 in a group, these parentheses mean group, plus 1 is the same as 4 plus 3 plus 1. You see how my group changed? Here my group is 4 plus 3. Here my group is 3 plus 1, but they're all the same number. So it all can be in a different order. The value will still be the same. 4 plus 3 is 7. 7 plus 1 is 8. Here it would be 3 plus 1 is 4. 4 plus 4 is 8. Okay? The value doesn't change. If you look at multiplication, 6 times 7 times 8, and remember, I taught you in our notes from yesterday, if a number is next to a parenthesis, it means multiply. If a variable is next to a parenthesis, it means multiply. So 6 times 7 times 8 is the same as 6 times 7 times 8. Okay, you see here my group is 7 times 8, but here my group is 6 times 7. I'm going to give you an example right now that is not associative. I'm going to put it over here on my flap. Not associative. And I want you to see if you can figure out why when I write it. Not associative. So, why isn't this one associative? I have a group here, I have a group here. My group over here is 4 plus 3. My group over here is 3 plus 1. That's a totally different group. Why is it not associative? This one is considered commutative. And this one is commutative because I changed things around. I changed the order around. In order for this one to be associative, I would have to have 4 plus 3 plus 1 and then just group it differently. So that's something that you need to be careful about when you see these. Okay? I'd have to have 4 plus 3 plus 1 equals 4 plus 3 plus 1, and then just change the grouping. If I did it here and then did it here, this is associative. It's a little tricky. Just remember, associative is groups. It's who you associate with. It's who you're grouped with. Okay? Grouping. All right, now I'm going to open both flaps, and hopefully you have room down here. If you don't have room down here to write, then put it on this flap. Commutative. I'll put a little star by it because it's important. Commutative and associative do not do not work for subtraction and division. They do not work. If you come across subtraction and division, you cannot do commutative or associative property. I can give you an example on another piece of paper of why. Let me grab a sticky note. So, if I were to do commutative property with subtraction, 2 minus 4 is not the same as 4 minus 2. 2 minus 4 gives me a negative 2. I cross over that 0 on my number line. 4 minus 2 is 2. Same thing with if I did 2 divided by 4 is not the same as 4 divided by 2. 4 divided by 2 is 2. 2 divided by 4 is 2 over 4, or half. These are not the same answers, so it does not work. Alright, I'm just going to show you the example with, oh no, I did division and subtraction. Okay, so this is our little top two flaps. Now we're going to go to the bottom. On the bottom, on the left, I want you to write identity, and these are the ones that might be new, that you might not have heard of, but for sure you'll be able to understand what they are. And for this one, you need to think ID. Like your ID card that will be sitting in my drawer at school, and hopefully I'll be able to give it to you someday. So I'm going to draw a little picture of your ID card from Zenker. Okay, there's my little ID card from Zenker. Identity property. There's two identity properties. I'm going to write one on this flap and one on the inside. Okay, so the first one is identity, and I'm just going to abbreviate with ID. ID means identity. Identity property of addition and subtraction. That goes on the inside. I'm not trying to change the identity of a number, meaning I'm not changing the value of a number. So adding or subtracting if I don't want to change a number, let's say I have 4. If I don't want to change a number, if I don't want to change 4, what number could I both add and subtract that makes it stay the same? That makes it 4. Hopefully you figured it out. Adding or subtracting 0 to a number doesn't change its value. So 8 plus 0, still 8. My identity hasn't changed. If I said Darren plus 0, I still get Darren, right? Okay. 100 minus 0 is still 100. It's like saying Sarah minus 0 is still Sarah. Okay, the identity hasn't changed. That number has stayed the same. But we also have the ID property of multiplication and division. And if you're thinking with your brain, you might be thinking of the number that we use that doesn't change the value of a number. So, what it is multiplication or division by what number? What number doesn't change the identity if I multiply it or divide it? If I multiply 8 by what? It's still 8. If I divide 8 by what? It's still 8. I hope you said 1 doesn't change its value. So 8 times 1 is still 8. 100 divided by 1 is still 100. So I'm going to write a big 0 over here and a big 1 over here, and that's the identity properties. Alright, we're almost done. Last one is zero property. And this is the easiest one. Zero property. I'm going to write in all caps like I'm shouting. Everything, underline it 3 times, multiplied, put a little cloud around that, make it fancy, by 0 is 0. Everything, anything you multiply by 0, it's 0. Doesn't matter what your number is, it's going to be 0. A cajillion multiplied by 0 is still 0. -5 times 0 is still 0. It's the rule. Everything multiplied by 0 is 0. Always remember that. Don't get tricked. Okay, so now that we have our little booklet here, what you'll do is you'll take the back side and you'll either put some glue on it or get some tape. I glued mine. And stick it into your notebook. This is from last year. On that page where we wrote properties. Let me find my glue stick. And stick it in the notes section of your notebook. And that way you have it in there. And you can remember commutative, associative, identity, and 0. Rules of numbers. And that is it for our notes today. You are still going to need to do independent practice 464 on the Google form and submit it. So you had notes and independent practice today, and then tomorrow we'll start talking a little bit more about how we use these with expressions and equations.